Hello, Math 141, talking about the pH scale. We know that pH equals minus log of H plus in brackets. So what is this symbol right here? This symbol H plus in brackets is reserved for the concentration of hydrogen ions measured in mole per liter, capital M. So you look at this and you wonder, was this necessary? And the answer is not absolutely necessary, but really helpful to avoid the very small numbers or a very or numbers with negative exponents. And let me go to the next page. Here is what I mean. Suppose if you measure the solution and you found that um, the amount of concentration of hydrogen ions happen to be, let's say, 10 to the negative 6. Well, 10 to the negative 6 is 1 over 10 to the power of 6, which is a million. So as you can see, you get lots of decimals. That's not really, you probably don't like that. And well, maybe not mathematicians, but most people don't like to work with negative exponents anyways. So let's do a few examples in here. And it's a good time for me to remind you that if you have a solution such that the pH is less than 7, your solution is acidic. If you have a solution with pH of equal to 7, then your solution is neutral, like water. If you have a solution with pH greater than 7, then your solution is basic. Let's do our first example. Suppose you measure a solution and you find that the hydrogen ion concentration is 3.11 times 10 to the negative 8 mole. So hopefully you can agree that this is not a very friendly number. Okay. And so you want to turn this into pH. So you can say that pH equals minus log base 10 of H plus. Okay. Let me put the base 10 here just for the heck of it. And so pH equals minus log of 3.11 times 10 to the negative 8. And if you put that in your calculator, you roughly get a number really close to 7.5. And that's a much nicer number to work with. So is this sample basic or is it acidic? Well, the pH is greater than 7, so this sample happened to be a basic sample. Now, what if you were given, okay, you were given the pH and you wanted to find out what's the amount of hydrogen ion concentration? How would you do that? Let's go to the next page and suppose another example. And suppose this time you know that pH of a solution is 2.5. Okay. And you want to find the hydrogen ion concentration. Okay. So how do we do this? Remember that we said that pH equals minus log of H plus. Okay. Notice that if I multiply both sides of this equation by -1, I will get minus pH equals log of H plus. And notice that now I can claim that this base to this power equals the argument of the logarithm. So now I can claim that 10 to the minus ph equals h plus. Okay, so now I can say that let me write here that my h plus is going to be 10 to the negative 2.5. Okay, let me put that in calculator. 10 to the, okay, I get a number 0.00316227, okay, and on and on. And so what if I wanted to put that number in scientific notation? I could claim that this is, let's see, 1, 2, 3 decimals. So 3 times 10 to the negative 3 is, and let me put M for mole. Okay. So now we know two things. The first example, we learned how to find the pH given the hydrogen ion concentration. In the second example, we learned how to find the amount of hydrogen ion concentration per mole. So going backward, let's do one more example just for the sake of discussion. Let's say we have an unknown substance that has, we have an unknown solution, okay, with hydrogen ion concentration of 3.2 times 10 to the negative 4 mole. Okay. What's the pH? Find pH. Okay. So I can say that pH equals minus log of H positive or plus, that equals minus log of 3.2 times 10 to the negative 4. Okay, that roughly equals 3.5. And notice that this time, this substance is acidic. This substance is acidic. Okay. Let's do one really interesting example. The question in this example is asking how many times more? How many times more acidic is acid rain is acid rain with a pH with a pH of 2.5 than ordinary rain. Ordinary rain with pH of 6. Okay, so I think the answer to this problem is going to totally surprise you. Okay. So we know that pH equals minus log of H plus, okay? And we solved for that and we got, after we solved for that in previous problem, we multiplied both sides by -1. Let me write it for you, just for the sake of discussion. Minus pH equals log of H plus, and then we said that this base to this power, in other words, 10 to the negative pH equals to H plus. Okay. So we, the acid rain, so we want to know the ratio of acidity of a rain with pH of 2.5 over 6. So for acidic rain, I have 10 to the negative 2.5 over 10 to the negative 6. Remember, this was for regular rain, ordinary rain, and this was for acidic rain. Acidic rain. Okay, so if I simplify this, this is the same as 10 to the negative 2.5 times 10 to the power of 6, and that gives me 10 to the power of 3.5, and that almost equals 10 to the power of 3.5. Whoa, you're not going to believe this. 3,162.27766, so roughly equal 3,162 times more acidic. Wow. Okay, I hope you like these examples. I'll talk to you soon. Thank you.